So I start in Visual Studio with Gigi Edit in the release. I make a new shader that I call test. And I want to refer a file here, and I want to work in that folder here. So let's do new here, test.hlsl. And then I want to refer to this one, so ... pick it up. Currently it's an absolute path because it doesn't know yet where the Gigi file is. But if I do save as, and then save it into the same folder, let's call it test, then let me see. Yes, now it's an absolute, now it's a relative path, so that's better. Okay, so I have the shader made. Now I make a compute shader node and tell this compute shader node it should use that shader. I create a new texture, and I want to use that as an input. So I need to tell this shader that he has inputs, which in this case is a resource. It's inputs or outputs is a resource. So let's call this guy output and give it a read-write access because I want to output to it. And it is a texture, and I can hook it up. Float 4, that's okay. Okay, so now this guy should have a format and a size. So let's pick a format that is good for the eyes. It's nonlinear sRGB is good. And then it should have a size. Let's make it 256 by 256. I will change that later probably. Here. Okay, and then this guy should also use the same size for the dispatch. So it's a compute shader that needs a dispatch. So it should use the same size. So I can just pick node 0, which is that node, the size of that one. Okay, I save this. And now if I open the viewer, okay, so there's an error. Let's open this file. Write the compute shader. Now I always forget how the syntax is exactly, but you also don't have to remember it because there's an example in shader to human. You just go in here into examples. And there's one example for compute shader, one for, well, two for pixel shader and vertex shader. And those ones, this one is a floating 3D quad in world space. And this one is in screen space, so it's always aligned to the screen. So they look alike, but this one is a compute shader version. Stick to the compute shader version. So you can write it more or less the same, but important for the syntax is you need, for Gigi, you need these three things. So you need to say where the resources should go, what compute shader size, that's what HLSL wants, that's the thread group size. And then here's the XY coordinate, which thread we're actually talking about. And that should at least run. Let's see. Doesn't work yet. Oh, I think I named it wrong, because this guy should be named main. That was the default name. Yeah, there it is. Now it doesn't write to it. I called it output, and you can just access output at this location and just write the value in it. And in this case, it's best to have the alpha channel 1. So it's red, green, so that's yellow. And then alpha channel 1, so this is opaque. So then you should see it. Did I? I think I got an auto completion. That's what I wanted. Yeah, works. So now I want to include shader to human. So you can grab shader to human by just Googling for it. Type in shader to human in Google, and then you will find on GitHub the repo. And that GitHub repo, you don't need the whole thing, but you just need the files in the include folder. But if you download zip, then it downloads everything, which is not too large either. And then you can just open and just copy that include folder. So I do that now and put it into my folder. One thing you need to do is you need to tell Gigi edit. So I'm switching to Gigi edit. You need to tell it that you want to use this include. So you cannot just include it by yourself. If I would do that, then I would get an error. Let's see. So it is s2h.hlsl that I want to include, but I put it in an include folder. See this file? And then I need to write include before. So, but it will, I mean, this HLSL would like to do that, but Gigi needs to know that file in advance. So you would get an error. Prevent that error, you just need to add this as a file copy. So new, ... include, and then I'm only doing this one, the other one I need to do later. So now it should copy those ones over, and I need to tell it that it's a shader. Okay, saved it. Now if I go into the viewer, that should work. Well, it doesn't complain, so it works. Okay, so now I want to make use of the shader to human. So I included it already, and if you open this file, you can see a little documentation that says you should include this file, and then you should use it. So I'm copying this part. I also do that myself when I need it. So let's do this. So you need to make a variable UI, it's called UI, and then for of the type context gather. That's just a documentation. And then you need to call s2h_init with that variable and with a pixel position. In our case, we're in the compute shader, this pixel position, we get this from the xy, from our thread number. And then we have an example which is printing out something, just A and B. And then this part here depends a little bit on your output. So currently I'm having an sRGB color output. So because shader to human is computing in linear space, you would have to convert it. You might not see an immediate difference, but with subtle color changes, you might see that. So this would work. And it's correct. So this solves the problem. Here it says linear color. So the linear color is, sorry. The linear color is blended together with the background and shader to human. In this case, I had a background before, which was the yellow color. So let's put the yellow color into the background. So linear background is my yellow color. And it was also opacity, sorry, the alpha channel was white. So that would work. Should work. Let's see. Okay, we get an error because linear color is undeclared. Linear background, linear color. Okay. Sorry. Okay, and there you see A and B. So it works. Now I want to make this a little bit easier to read. So the size and the, actually it's not yellow. Let me see, why is it not yellow? Linear background, yes, here should be yellow. Okay, now. So that's the convenient thing with the hot reloading. You just save it here and then immediately it loads on the other side. But now it's even harder to read. So let's just change something. Let's make the background a little bit less vibrant. Let's make it gray. And then also the AB, it looks large here right now because I'm zoomed in, but honestly, when you're looking at it 1:1 resolution, it's very small. So I'd like to make it larger, and there's commands for that. So you can do set scale. If you forget about those things, you just go into that include and your scale. You can either set it directly on the UI, because it's a struct, you can directly access it, or, which might be more convenient, you call set scale. It might be those functions do slightly better things, so there's no class concept in HLSL, and maybe there is at some point, but GLSL might not have it either, so just to keep everything simple, it is a struct, so you can access it, but you might want to use the functions if they exist. Some stuff there is no functions. So now you can set the scale. Let's set it to 4 and see there should be much larger. Oh, of course I have to set the scale first and then print. Okay, and then the position of where I want to print. So set cursor. Now I can change a position. It doesn't have to be int to a float. Well, it can be int to a float too. It doesn't matter, but just to show you. Okay, and again, I did it under. So there we go. Now if I want to print out a number, and this is more useful than text in most cases, is if you just print out a number, then you print in int here, and see that's the number. And that's very useful. This is one of the major things that Shader to Human makes very, very convenient that you normally never get. If you want to print out a float, you can do that like this. And now if I do this, you see it's just behind it. And that's more visible when you do, see, it's just behind it. And that's not so useful in this case. So you want to go for the next line. So you do print line feet, and that's it. Now you have the next line. And you see, because of that set cursor, it knows where the lines start. This is one of the differences. If you would by hand change UI dot and change the XY position of the cursor, you would not get this as a feature. So that's one of the benefits. But let's just see how set cursor is implemented. Cool thing is that you can look at this. So it knows additionally where's that left position and remembers that, so that when you go for the next line, it's fine. Let's change the text color as well. So in this case, there is no function as far as I know. This is bad autocompletion. Text color. I thought it's text color, but I verify now. Yeah, should have auto-completed. Equal, and then you don't have to change the alpha. So in this case, I just overwrite the red, green, blue. And let's make it red. There we go. You don't have to do this for both lines, so we can do it for the second line only. So what else we can do is, let's say we draw something. So let's go through a few functions. So Shader to Human, we only included that file. So we already did, if you want to check on the version number, you can do that, make it backward compatible if some big changes happen, but so far that hasn't happened yet. So these members you can change, but interesting is the functions. You need to call the init first once. You can change the cursor, we did this. Dinit is useful for interactive UI, we need that later. Set scale I showed you, print text we used, print space, you just make 20 spaces if you want. Print line feeder showed, int hexes can also be useful for hexadecimal numbers, float we had that. Print character is just a simpler version than print text, so it's kind of print text calls print character multiple times. Print disk and box is just similar shaped to a character, but a disk or a box. Frame makes a little border. Draw disk, draw circle. Let's get for a line, let's say. And you see here, at least some, it says here, begin, end, and color. Okay, let's do this. Let's do 1010. 110, and then color white. And I used white here as 1 because this is a float 4 and 1 becomes 111. 1. And if you want to, let's say we take white, so 111, but then you want to have it half see-through, so 0.5, then it is more faint, or make it even more faint. See, and you can make it thicker too, and this is not on the function itself because you might want to use that with multiple line functions. So this is inside here. There's a line width, so UI.lineWidth allows you to adjust that. So now we have a thicker line. Okay, and then let's go a little bit down. Oh, let's make it a little bit angled. There we go. Now, currently, it's, see, the scale is is not 1. So now the scale is 1. And if you zoom in, you can see it is anti-aliased. It has more shades here. So that's a feature of that line drawing. And that's why you also have to specify floating point coordinates. There's some other, like there's a draw rectangle. Here, see, there's one with anti-aliasing, and sometimes you want that, but sometimes you don't want that, so you have also a draw rectangle without anti-aliasing. And you can draw other stuff. Let me do one more thing here, like the draw sRGB ramp. That is useful to verify what we're having on the screen actually is correct. 0 is just a position, so it puts it on the left top. And now you can see let me just do this one. Looks a bit strange. Okay, well now I see there's a nice gradient. This one is half gray, it's 127. And I can verify that my image looks right. So I can do, for example, I can copy this image. Then I open in Photopea, one of my favorite programs. Like a Photoshop, but online and free. So I pasted it in here, and now you can verify. First of all, we want to see here a nice gradient. Every pixel should have a different color. So it's 256 pixels, so we're going to have different colors. And if I pick one of those ones, the middle one here, this one, should be, if it's correct, 128 or 127. So this is good. We're outputting the right thing, and that's because we did this call to the conversion function, to this accurate linear to sRGB. If I wouldn't have done that, if you would just output the color, it's too dark. So this is wrong, because linear colors is not what you want to send to your graphics card. Somewhere there has to be a conversion to sRGB, and then the monitor displays that one correctly.